So in this video, all we're going to do is just a few problems of abstract inequalities so you guys can get some practice. So every time, try and pause the video and try and do the problem before we do it, just because it makes it more interesting for yourself instead of sitting there. So the first thing we have is b squared plus 1 is greater than or equal to 2b. How are we going to prove that? So first thing, we're going to move everything over to the left-hand side. So we're going to have b squared minus 2b plus 1 is greater than or equal to 0, because it's easier to prove that things are greater than or equal to 0 than that they're greater than or equal to another number. Okay, so now hopefully we spot that this is the perfect square. So I'm going to say b minus 1 squared is greater than or equal to 0, because that's how you perfect this square here. B minus 1 squared will be equal to this if you multiply it out. And this is true because any positive number is always greater than or equal to 0. So that's our first one done. Handy enough. I'll scroll down and we'll write the second one out. So here's our second problem here. We have to prove that c plus 1 over c is greater than or equal to 2. And they also tell us that c is positive. So c is greater than 0. That means that c is positive. Okay, so what we're going to do is we're going to multiply everything by c to get rid of this fraction here. And we can do that without changing the direction of this thing. So remember back to inequalities, if you multiply something by a minus number, you have to change the direction of the inequality sign. But because we know that c is positive, we don't have to change the direction, all right? So if you multiply c by c, you're going to get c squared. If you multiply c by 1 over c, you're just going to get 1. And if you multiply c by 2, you're just going to get 2c. So now I'm going to move this over to this side again. C squared minus 2c plus 1 greater than or equal to 0. And again, we're going to try and perfect this square. And it's going to give us c minus 1 squared greater than or equal to 0. So hopefully you guys got that one as well. Don't forget to pause the video. And that one is always true again because it's a positive number. Yeah. So you have to be able to spot those perfect squares like that: b squared minus 2b plus 1, c squared minus 2c plus 1, etc. How to perfect those squares. And the reason there's a plus there again is just minus 1 by minus 1 will be plus 1. We'll go ahead and we'll try the next problem. So this is our next problem here in red. So it says if x and y are in the set of natural numbers, prove that x plus y multiplied by 1 over x plus 1 over y is greater than or equal to 4. Alright, so this thing is the first thing we're going to look at, that x and y are a set of natural numbers. So natural numbers, remember, that's 1, 2, 3 and so on. So that means it's the same as c is greater than 0. In this case, x and y are both positive. So we can multiply by x or y or any combination of those two, and we won't have to change the direction of this inequality sign. Alright, so that's a useful thing to know. We will start this problem by multiplying this bracket out here. So again, if we have, I'll just do it over here, I got right over here. If we have x plus y multiplied by 1 over x plus 1 over y greater than or equal to 4. So if you multiply x plus y by each individual fraction, we're going to get x plus y over x, and then we're going to get x plus y over y, x plus y over y, and we aren't able to cancel any of those x's and any of those y's. Be careful about that. And the next thing we're going to do is we're going to multiply everything by xy to get rid of the fractions. All right, so I'll scroll down a little bit more. Ooh. Multiply everything by xy. So this is going to be xy multiplied by x plus y divided by x, and it's going to be plus xy multiplied by x plus y divided by y, and that's going to be greater than or equal to 4xy. Yeah, so each term is multiplied by xy. So now we can start cancelling things. This x is going to cancel with that x, and then this y is going to cancel with that y. All right, so now we're going to have over here, we're going to have xy, so y multiplied by x, plus y squared, so it's going to be y by y. And here we're going to have plus x squared, and then plus xy is all greater than or equal to 4xy. So I'm going to rewrite this as x squared plus 2xy, so xy plus xy will be 2xy, plus y squared is greater than or equal to 4xy. I know some of you might spot a perfect square here, but it's not the time to perfect the square just yet, because on this side we have another number. So remember, we have to prove that things are greater than or equal to 0, because it's much easier to do than proving that things are greater than another number. So I'm going to bring this 4xy over, and we're going to get x squared minus 4xy plus 2xy plus y squared greater than or equal to 0. Keep scrolling. This is going to be x squared, so minus 4xy and plus 2xy will be minus 2xy plus y squared. It's going to be greater than or equal to 0. And now we can perfect the square. So that's going to be x minus y all to be squared is greater than or equal to 0. And this is true. And therefore, a statement at the start that what we're asked to prove is also true. Right? So hopefully that one's done. So we're going to look at one last abstract inequality. So I'm just going to scroll up and then scroll across. So our last one is going to be this problem right here in front of you. So the yellow one, prove that x squared plus 2xy plus 3y squared is greater than or equal to 0. All right. So this one's kind of hard because you can't perfect the square because of this 3y here. It's not very easy to do. So there's a little trick you have to do. So so we're going to say x squared plus 2xy, and I'm going to break this 3y squared up into plus y squared plus 2y squared greater than or equal to 0. All right, because y squared plus 2y squared is just going to be 3y squared. So I'm just writing this in a different way. So now this here is a perfect square. So now we can perfect the square. So I'm going to write that as x plus y all to be squared, and that's going to be plus 2y squared is greater than or equal to 0. And this is true because x plus y is a squared number that has to be positive, and y squared is another squared number, it also has to be greater than or equal to 0. So that means this statement is true. So that's all for abstract inequalities. Hopefully you guys enjoyed the video. That's kind of the most, like, there's going to be just more problems like that. They're all very similar and they're all based on the same principles there. So if you can get the idea of perfecting the square, completing the square, anything like that, you should be able to prove these abstract inequalities. So in the next video we're going to look at the proof that the square root of 2 is irrational.